We're going to start chapter 13, and we're going to learn how to add, subtract, and multiply polynomials. So the objective is students will learn how to add, subtract, and multiply polynomial expressions. The vocabulary that we need to learn for this, or be familiar with, is that each product in an expression is called a term. I'm going to go down here and show you a few examples here in just a minute. And the number being multiplied by a power is a coefficient. In an expression, a constant is a number on its own without a variable. So let's look at an expression. This is an expression, 5x squared plus 6. That would be an expression. So 5 and 6 would be my coefficients. They're the numbers in front of the variable, or the constant also counts as a coefficient here. The terms would be 5x squared, that would be a term, and then 6 would be the other term. And then the number 6 here is my constant. That just kind of gives us a little overview of some of the vocabulary you're going to hear all through this chapter. So a polynomial, that is also something we need to know what we're talking about. That's part of my objective, is to learn how to add, subtract, and multiply polynomials. So a polynomial is a mathematical expression involving the sum of powers in one or more variables multiplied by coefficients. So it looks something like down here. This would be a polynomial. It's a mathematical expression involving the sum of powers. Do I have that? This is a sum of powers here. I have an x cubed, an x squared, and I have a constant in one or more variables. So we have one or more variables here. We have one. We have the x variable, and it's multiplied. It can be multiplied by coefficients. If there wasn't a 3 here, my coefficient would be 1 on this. So polynomials that have only one term, remember what a term is up here, are called monomials. And polynomials with 2 terms are called binomials. And then polynomials that use 3 terms are called trinomials. And then the last bit of vocabulary that we need to go over is that the greatest exponent in a polynomial determines the degree of the polynomial. So this one, if we look at all of these, which is my greatest exponent? This one doesn't have an exponent, it's my constant. This one is x squared, and this one's x cubed. So my greatest exponent is 3. So that we'd call this a third degree polynomial. So just quickly as a review, coefficients are my number in front of my variable, or my constant counts as well, 5 and 6. And then terms are each term. 5x squared would be a term, and 6 would be a term. So we're going to go down here. I've done the first one for you. You're going to fill in the information that you need to know. So terms in number 1, negative 5x would be a term, and 8 would be a term. The coefficients on number 1 are negative 5 and 8. The type of polynomial, that's up here when we talked about if it was a monomial, binomial, or trinomial. This would be a binomial, and it would be a degree of 1 because I have an exponent here of 1. Even though we don't write that, it's assumed that it's there. 5x to the first plus 8. So if you're not watching this online, but you're in a class, I know Miss Major's class may be watching this right now, I want you to pause the video, and you're going to fill in 2, 3, and 4 right now. And even if you are at home, you ought to try to do this on your own before you check the answer. So this would be the time to pause. Hey, hopefully you paused it. Maybe you're coming back. If not, we'll just keep going here. So on number 2, the terms would be x squared would be a term. It's one term, and the other term would be negative 4x. Coefficients would be 1 and negative 4. The type of polynomial on this one would be there's only 2 terms. We go with how many terms there are. So since there's only 2 terms, we call it a binomial. And the degree would be 2 because x squared is my largest exponent. Number 3, the terms would be negative 3w cubed is a term, w squared is a term, and negative 9 is a term. My constant is a term. Sorry about the lighting on this and going in and out of being blurry. It has to do with our internet connection here. The coefficients would be negative 3. Now, the coefficient in front of the w squared is just a 1. We don't write it, but it's there. And then negative 9. The type of polynomial, let's count how many terms we have. We have 1, 2, 3 terms. So up here we look, that's a trinomial. Oh, I wrote that in the wrong spot. You'll have to forgive me. Put an arrow. Then the degree, this would be a third degree. So a degree of 3 because w cubed. Okay, last one. Terms. This one I would have 10, negative 3x cubed, and negative 6x are my terms. The coefficients would be 10, negative 3, and negative 6. The type of polynomial, I still have just 3 terms here. So this is a trinomial. I'm just going to put tri. And then the degree would be 3. So now we're going to learn how to add or subtract polynomials. To do that, we just combine the coefficients of like terms. So like terms means, see how x squared is a term and negative 4x is a term? These are not like terms. They'd have to have the same exponent and the same variable to be a like term. And so to do that, though, we just combine the coefficients of like terms. To multiply polynomials, we distribute and combine like terms. So let's first work on a few where we're going to add or subtract. All right, this one. I first want to get all my terms together. Now I have a parentheses here. The reason for parentheses is to tell me to do something inside of it first or to distribute if it's being multiplied by something, but it's not. We're just adding it, and there's nothing inside the parentheses to combine. So I'm just going to rewrite this and drop the parentheses on both of them. 2x cubed minus 5x squared plus 3x minus 9 plus x cubed plus 6x squared plus 11. And now I'm just trying to combine my terms that are alike. So I have a 2x cubed here. And so the only thing I can combine that with is if I have another x cubed term. So I'm going to grab my colored pencils here and I'm going to do all the x cubed terms in, let's go with green. So here's my 2x cubed. The other term that I can combine it with, I can't do 5x squared, I can't do 3x, I can't do negative 9. Here's another x cubed right there. Notice how I circled the sign in front of it, positive. That's how I know if I'm going to add these two together or subtract. And then I have 6x squared, that doesn't go, and 11 doesn't go. So I'm just going to take 2x cubed and I'm going to add x cubed to it. Now remember, there's a 1 as a coefficient in front of this. So to add or subtract, I just combine the coefficients of like terms. So 2x squared plus x, or 2x cubed plus x cubed would give me 3x cubed. I'll go ahead and write it in green. We'll make sure that you can read it. There we go. All right, my next term is a negative, or I have x squared. So I'm going to look here and see if I have any other x squared. I'm going to circle the negative in front of the 5x squared because that goes with the 5. It is negative. Okay, this isn't. I've already used this one. I can kind of cross it off my list here. 6x squared, oh, there's another x squared term, so circle that one. And then 11 is not, that's a constant. So I have negative 5x squared plus 6. Remember, I just add the coefficients. So negative 5 plus 6 gives me a positive 1, and then I keep x squared. So the best way to write this, instead of writing 1x squared, would just be plus x squared. We don't need to write that 1 in front of it. Okay, x terms. See that one in this color. I have a positive 3x, and that's it. So I don't combine it with anything. I just put plus 3x right here. And then the very last one, I have my two constants. We'll do those in pink. So I have a negative 9 and a positive 11. Of course, you do not have to do this with colored pencils. You can do this however you want. But this is just for you to see. A negative 9 and a positive 11 gives me a positive 2. So that is how I add or subtract polynomials. I just combine the coefficients of like terms. I'm going to let you do 2, 3, and 4 on your own. I will pause the video and I will just post the answers after, so check your work. Okay, here's the answer you should have got on number 2. And I told you to do 3 and 4, but I actually want to, and if you did, that's great. I'm going to point something out here. If you don't get the right answer, I want you to check to make sure that you remember to distribute that negative. This is like saying all of this right here times a -1. So I have to go through and change all the signs inside the parentheses, because that's what happens when I have subtract this whole parentheses. I have to distribute my negative. So I'm going to post the answer here in just a second, but if you get it wrong, please double check that you distributed that negative. Okay, here's the answers to 3 and 4. I want you to notice one thing. I didn't specify that order mattered, but on a polynomial, we always like to write them in descending order, which means we take the highest exponent first, then the second, and we go all the way down. So we usually put our constant last. Okay, turn to the second page, and on this page we're going to find the product of the polynomials using the distributive property. So first thing on number 5, you can't see the number up here, but this is number 5. To use the distributive property, I'm just going to times this through 5x squared times 6x plus 2. So 5x squared times 6x gives me a 30x to the third. Now x squared times x is x to the third. Don't forget that important property here. Then plus 2 times 5x squared is 10x squared. So that's all I need to do on number 5. See if we can get this to focus again here. There we go. So I just distributed my 5. Remember the x times x, I have to add my exponents on this. So 2 and 1 gives me 3. All right, 6. Distribute my 3 and I get 3x squared plus 18x. I just took 3 times x, added my exponents, so they both have a 1 right here. So it would be 3x squared. And then I took 3 times 6 and I got 18x. Okay, on number 7, let's first go 6x squared times x. So this would be 6x cubed. And then 6x squared times 2 gives me plus 12x squared. Okay, that's how we use the distributive property. That's a little easier. You notice here we only have one term. This would be a monomial multiplied by a binomial here. So on that, we just distribute. What if we have 2 binomials? That's this. Remember, a binomial is something with 2 terms. So I have 3z plus 1 and I have z minus 3, and I need to know how to multiply those two together. Well, there's 2 methods. The first one is the garden method. The garden method helps you stay organized a little bit more, but sometimes it takes up a lot of paper. And as you really get used to how to do the garden method, you're probably going to, or the FOIL method, and you learn how we multiply polynomials, you might ditch the garden method eventually, but sometimes it makes it easier. So on this one, what we do is we just take this z right here, and to fill in this box, we have to times it by the 2 numbers that are on the side of the box. So it would be z times 3z. That would give me 3z squared. I know in science you do something like this. Can't remember the name of it. But anyway, you know what I'm talking about. Z times 1 would fill in this box with the z. Now we come down and fill my bottom 2 boxes. So I have to go -3 times 3z. And I get -9z. And then I go -3 times 1 gives me -3. Now to finish multiplying this, I'm just going to rewrite everything I have. 3z squared. I have a positive z. I have a -9z. And I have a -3. Notice in the middle I have 2 like terms. They both have a z right there. So I'm going to combine those. So 3z squared. Now positive 1 and -9 gives me -8z. And then have -3. So that's the answer using the garden method. This other method is called FOIL. And FOIL, we call it that because it stands for something. We say first, outside, inside, last. And that goes with each letter. First, outside, inside, last. So it reminds us that the very first thing we do is multiply the two first terms. So 3z and z are the first term of each binomial. So I'd go 3z times z gives me 3z squared. And then I go 3z times negative 3 gives me negative 9z. That's the outside terms. Now I need to go to the inside terms. So that would be 1 and z, so it would be plus z. And then I go my last terms, 1 and 3, minus 3. Notice I got the same thing here as I got over here. So I just combine my like terms and I get 3z squared minus 8z minus 3. So just a little reminder on your notes I wrote down here to remember that x times x is x squared. So if I take 5x times 2x, that would be 10x squared. Find the properties of the polynomials using either method 1 or 2. So we're going to practice this now. On 8, and you should be, if you're doing this live in class, pausing the video right now and working on these on your own and then checking the answer afterwards. So I'm going to go ahead and keep going, but if you're in class right now, pause the video. So x plus 1 times x plus 1. So if I do the FOIL method, I'm going to do them both ways. I'm going to do FOIL method first. I would go first, so x times x would be x squared. And then O stands for outside. So outside means I take x times 1. They're both the outside terms here. So I'm going to go x times 1, so plus x. And then I stands for inside, so now I do my two inside terms. So I have 1 plus x gives me plus x. And then last, my two last terms are 1 and 1. So that would be plus 1. So now I just need to get my combine my like terms, and you'll find most of the time on polynomials or binomials like this, our two middle terms are going to be the two that I need to combine. So it'd be x squared plus 2x plus 1. So hopefully you got that answer. If not, look back at my work, make a note to yourself what you need to do. So this one, let's do the garden method. So on this one I got to draw a little box here. Okay, and above it I'm going to put 2x right here, and then I'm going to put 3 right here. That's my 2x plus 3. So both of them are positive here. And then I'm going to have x right here. Now my 2 is negative, so I'm going to put negative 2 right there. Now I just fill in the boxes. So x times 2x is 2x squared. X times 3 is 3x. Negative 2 times 2x is negative 4x. And then negative 2 times 3 is negative 6. Now I just got to rewrite all of this that's inside the box. So 2x squared plus 3x minus 4x minus 6. So combine my two middle terms because they are the same. So 3x squared positive 3 minus 4 gives me a minus x minus 6. Okay, I like to do the FOIL method more often because it takes less room. And sometimes in math we run out of room. So I'm going to actually do this on the FOIL method. Now if it says 8x minus 3 and you didn't know how to do this when you try to do this on your own, remember that squared just means I times something by itself. So I'm going to go like this, 8x, I'm just going to rewrite it here again. So 8x minus 3 times 8x minus 3. Now I just need to FOIL it out. So if I go first, I go 8x times 8x is 64x squared. Outside would be 8x times negative 3, so that's negative 24x. Inside is negative 3 times 8x, so negative 24x. And then last would be negative 3 times negative 3, so that would be plus 9, positive 9. If I combine my two middle terms, I get 64x squared minus 48x plus 9. Now I do occasionally make mistakes on my notes, so if you find something that I've done wrong, don't be afraid to question it to the teacher. Come in and ask at class. A lot of times I'll do the notes before I teach them, and so sometimes I'll make a little mistake and then can't fix my video. So go ahead and let me know if you find something. Alright, now we've got a few challenge ones below. I want you to think about this on your own if you're at home watching this, or if you're during class, pause the video and discuss with the group how you think we're going to do the ones below. Now these ones are different. Number 11 has a binomial times a trinomial. So FOIL really only works for when I have two binomials. Then this one has three binomials. So does this one, 13. So I want you to think about how you will solve those and discuss it with your group, or think about it if you're at home and fill in what you think on this. And it's okay if you fill in something wrong here, as long as you put a star and fix it if it's incorrect. Okay, let's talk about this. I want you to think of these, this is like multiplication, right? It's saying this number times this number here. So on FOIL method, we really just used the distributive property. We took 3z and times it by both of these numbers, and then we took 1 and multiplied it by both of these numbers. So I can do the same thing down here using the distributive method. The garden method also works for this one. Sometimes it's a little easier to see this one using the garden method. So I'm going to go ahead and do the garden method. And I'm going to now have to do 3 numbers across the top and 2 on the side. So I'm going to put 2a and negative 3 right there. And then I'm going to put a cubed, negative 10a, and negative 2. Now I just fill in the boxes. 2a times a cubed is 2a to the 4th. Add my exponents there. 2a times negative 10a is negative 20a squared. 2a times negative 2 is negative 4a. Negative 3 times a cubed is negative 3a cubed. Negative 3 times negative 10a is 30a. And then negative 3 times negative 2 is 6. And now I have to rewrite all of this, kind of a little bit out of room. So I'm going to go ahead and write it up here if you're okay with that. So let's just start with this box. 2a to the 4th minus 20a squared minus 4a minus 3a cubed plus 30a plus 6. So if there's not a sign, see these ones are positive. When I put them back up here, I make positive right there. And now I just need to combine my like terms. So a to the 4th is the only a to the 4th. So let's write it down here. 2a to the 4th. Okay, and then I have 1a cubed term, so I'll put it next, minus 3a cubed. Then I have 1a squared term, so minus 20a squared. And then I have negative 4a and positive 30a gives me a positive 26a. And then plus 6. So that is my final answer to number 11. Okay, number 12. If we remember on this one that multiplication is commutative, that means order doesn't really matter. What I can do is actually multiply those two together first, and then take that answer and times it by x plus 3. So let's pretend like this x plus 3 isn't there for a minute. Maybe I can put something to cover it up. Let's just FOIL this one out. So first would be x squared. Outside would be negative 7x. Inside would be x. And last would be 1 times negative 7, so negative 7. So x squared minus 6x minus 7 when I simplify that. Now I need to take this and now times it by x plus 3. So if I'm thinking of distributive property, I need to take x squared and times it by both of those, then take negative 6 and times it by both of those, and then negative 7 and times it by both of those. So I'm going to cover this up for just a minute for my notes and just write over the top of it here, so I give myself a little more room. So x squared times x gives me x cubed. X squared times 3 gives me a positive 3x squared. Now I take my middle term. So negative 6 times x, negative 6x times x gives me negative 6x squared. Negative 6 times 3 gives me a negative 18x. Then my last term here, negative 7 times x gives me negative 7x. Negative 7 times 3 gives me negative 21. Okay, now I just need to combine all my like terms. So x cubed is the only x cubed, so we'll say x cubed. 3x squared minus 6x squared is negative 3x squared. And then negative 18x minus 7x gives me a negative 25x. And then minus 21. And that would be my final answer here. Alright, on 13, we're going to solve that the same way we did number 12. So I'm going to leave that one as a challenge problem to work out on your own. And we're going to go down here to the graph, the very bottom. The following functions are graphed on the coordinate plane below. So let's check out what we've got. We've got b of x, and that equals negative 18x plus 20. We should know by now what a graph like that should look like. My slope would be negative 18 over 1, and my y-intercept would be 120. So this is a line. So if I look, it labels that this is b of x right here, but my y-intercept is at 120, and my slope, I would go down 18 over 1. So that looks like that's that line right there. It fits that. The next one, h of x. You guys don't really know what a graph of this looks like yet. We haven't really talked about it, but I'm going to show you. When we do these x squared terms, we actually call it a quadratic. And it looks like a parabola, little dish here. So this is my h of x, the one here in black. That's what the graph of that equation right there looks like. Okay, t of x, I'm going to add this parabola to that line. I haven't really seen us do this before, but let's just take a look here. If I add this equation plus this equation together, I get this t of x equation that's in red. We're going to explore that a little bit more as we talk about, we're going to go down here and explore why that works that way. Okay, d of x is when I subtract them. So I take this line and I subtract this parabola from it, and I get a parabola that looks like this. So let's see what those equations look like. It says evaluate the following algebraically, but then use the graph to verify your answer. So I'm going to evaluate b of x at x equals 10. So if I come over here to 10, x equals 10, that's right here, it says evaluate b of x. It looks like it's just below the 50. So I'm guessing it's about 50-ish. I'm going to put approximately negative 50. But let's now do it algebraically. So that means I have to substitute x equals 10 into this equation. So that's negative 18 times 10 plus 120. That would be negative 180 plus 120 gives me a negative 50. So it actually is right at negative 50. Even though it looked like it was a little bit below, but that's where it is. Okay, 15. Evaluate t of x. That's this one in red when x equals negative 2. I like to first see what number I should be getting and then put it into the equation. So t of x at x equals negative 2. Here's negative 2. I come up here to t of x, and it looks like it's about 210. We'll just put about 200 just to kind of give us an idea of what we're shooting for. So let's put negative 2 into this equation. So t of x is b of x plus h of x. So I first need to find out what that is. Well, let's write that. So that means I have to take this, and I have to go negative 18x plus 120, and I need to just add 4x squared minus 5x plus 25 to it. I just added these two together, all the numbers. So this gives me, when I simplify, I'll put my 4x squared first, and then I go 18x minus 5x gives me negative 23x. And then I have 120 plus 25 gives me plus 145. Now I'm supposed to plug in negative 2. So 4 times negative 2 squared minus 23 times negative 2 plus 145. Negative 2 squared is a positive 4. 4 times 4 is 16. Okay, negative 23 times negative 2 gives me a positive 46, and then plus 145. So if I add all of those together, I'm just going to grab my calculator to be a little bit quicker here. We go 145 plus 46 plus 16, and I get 207. So that looks like that'd be about right, because we were saying about 200. Okay, you do 16 and 17 exactly the same way, but 16 you're going to evaluate h of x at 8, negative 8, so you're just going to plug negative 8 in for x up here and solve it. And then 17 you're evaluating d of x at x equals 7. So my equation for d of x is now b of x minus h of x. So I would set that up like this. Negative 18x plus 120, and I would put minus this whole thing in parentheses. Minus h of x would be 4x squared minus 5x plus 25. And then when I distribute my negative, I change all these signs. And after I do that, I'll plug in x equals 7 and compare it to what number I thought I should get on the graph, which would be, if x equals 7, d of x probably goes somewhere down around here, probably about negative 200 or negative 150, something like that. H of x at negative 8, go to negative 8, go up to h of x. That looks like it's about 325. So if you get in that range, and I'm really guessing on this one the most, then you're probably right. So that's how we do that section.